This is Radhika. I am going to discuss about the power electronics video lecture. Already we discussed number of classes about power electronics subject. Today I am going to discuss about applications of power devices, and also in this subtopic is we are going to discuss about the light dimmer circuit and burglar alarm. So, in last class, we discussed about the concept of UPS and classification of UPS. So, today our topics are types of batteries in UPS, their applications, and light dimmer circuit using track and diag, and also we are going to discuss about the burglar alarm, means theft alarm. So, actually, the storage batteries used in UPS is a stored battery is a very important part of inverter system and UPS. For low and short backup periods, for low and short backup periods, sealed maintenance free batteries are currently used with UPS for power off timings up to 1 hour. For medium power UPS, the ampere hour capacity of around 7 hour amperes is sufficient to provide a backup for above half an hour. The selection of battery and its capacity, nature of load, capital investment, backup period and efficiency. We can select the battery using of capacity of actually nature of load, and also we can observe the capital investment and backup period, and actually what is the efficiency of circuit. And also it has the for low and short backup periods, sealed maintenance free SMF batteries are used here. Just you can see the low and short backup, you can use to SMF batteries, means sealed maintenance free batteries. For low and short backup UPS, we can use the sealed maintenance free batteries. For high rating large batteries, we can use the lead acid batteries. For higher rating and large backup period, lead acid batteries are used. These are either parallel plate type or tubular type. So, this is the SM in sealed maintenance free batteries are costlier than lead acid batteries but have longer life, about 4 to 6 years. Means the sealed maintenance batteries are costly but it gives the long life. Here the battery has few specifications, that are the battery EMF is 6 volts, 12 volts or 24 volts. Terminal voltage 1.8 volts for single cell, 5.4 volts in case of 6 volts battery. Internal resistance of the order of 0.01 ohm. Capacity of battery is, it is the quantity of the electricity the cell can give during single discharge till its terminal voltage falls to 1.8 volts. The ampere hour efficiency is, typical value is 90 percentage and whatever efficiency is 75 percentage. So now we are going to discuss about the light dimmer circuit using diac and triac. So in the circuit we can observe the AC mains, one switch and one triac, one diac, one lamp, and the resistance and capacitor will be connected in series with the diac. So here in this circuit, the light dimmer circuit to control illumination level of a lamp using diac and triac. The RC circuit forms the triggering circuit for diac when voltage across C is sufficient to cause conduction of diac. A gate current flows in the gate circuit of triac. The triac starts conducting and the lamp glows. Charging resistance R causes change in firing angle of triac and voltage applied to the lamp changes, thus changing its illumination level. The fixed resistance R1 ensures that gate current does not become more than the rated current even when the resistance R is at its minimum value. So here in this, when the voltage across C is sufficient to cause conduction of diac, a gate current flows in the gate circuit of triac. The triac starts conducting and the lamp glows. Changing resistance R causes change in firing angle of triac and the voltage applied to the lamp changes. The changes its illumination level. So working is the fixed resistance R1 ensure the gate current does not become more than the rated current even when the resistance R is at its minimum value. Now we can watch the one YouTube video for using of the above circuit is light dimmer circuit using diac and triac.
So the circuit diagram drawn here is the circuit diagram for diac triac light dimmer circuit. So from this diagram we can see that we have used a bulb which is a load for our circuit, a potentiometer which is a variable, fixed resistance R, a capacitor C, and along with that a diac and a triac. So the aim of our experiment is this: along with the use of diac and triac in one single circuit, we'll try to change the intensity of bulb along with the change in the value of potential resistor spot, and we'll change the firing angle of triac which we'll see on the CRO. So as we can see, we have given a 230 volts AC supply. Accordingly, we'll change the value of potentiometer and we'll observe the readings on CRO and we'll see the change in intensity of bulb.
So as per the circuit diagram, we know that we will be using the voltage supply from the AC voltage supply of 230 volts and 50 hertz. But in order to keep the protection of the mains, we have used an ultra isolation transformer. The ultra isolation transformer is an auto transformer which is going to isolate my supply voltage to my circuit. So if there are any sudden surges or any sudden things which are not favorable, then the mains won't be affected by it, and hence it is a protective measure taken by us in the designing of the circuit. What we have here is a varistor in which we have already set 80 volts using this variable knob. The 80 volts go into the board at the AC input side of 60 to 80 volt section as noticed here. Then the load part which has been mentioned here is directly connected to the CRO. Currently the circuit is completely off, so we notice that there is no reading in the CRO. After that so this is the potentiometer knob which has been the 100 kilo ohm potentiometer knob. This is the switch which is off currently. On pulling it down it will be on, This is the light bulb, which is the load basically, where we will be seeing the dimming of light in terms of intensity. And
So we see here that we have started our supply, and on making this on, we see that our bulb is glowing. And when we proportionally change the when we change the value of the potentiometer, that is changing the resistance, our a bulb intensity also changes proportionally. So similarly, we can see this hole on the CR2. So this is our graph, and as we see, while increasing the resistance, we can see that the firing angle also changes, and as we decrease, the firing angle decreases. And we see that in dioptric light dimmer, we don't get a complete 180-degree firing angle.
So as we have performed dioptric light trigger experiment, we saw that with the relative changes in the value of firing angle and changes in value of potentiometer, the relative intensity of bulb is changed. Higher the value of firing angle, higher will be the intensity of bulb, and vice versa. The firing angle of triac is given by pi minus alpha. Here we saw that we do not have 180-degree firing angle, as the formula of our firing angle is pi minus alpha, so we don't have a firing angle of 180 degrees. Now on the basis of our experiment, we'll see the graph which we obtained on CRO at different values of firing angle. The diagram which we see here is the graph with the minimum value of firing angle. We can see that in this graph that our triac is on for the maximum amount of time and the off time of triac is less. This is the graph we obtained when the firing angle becomes 90 degree, that is alpha is equal to 90. Here we can see that triac has on time and off time 50%, that is triac is on for the half of the time and it is off for half of the time. We obtained half positive cycle we obtained half positive and half negative cycle. So these are our values and observations when firing angles become exactly 90. This is the graph we obtained when the firing angle is maximum, that is 145 degree. From this we can see that triac is off for majority of the period of time in positive and negative cycle both. We can see that we just obtained a spike of a voltage on both the positive and negative cycle, that is the on time of triac, which is very less, and the off time of triac is for the majority of time. This we obtained for the maximum firing angle, that is 145 degree.
Now we watched the one YouTube video about the light dimmer circuit using track and diac. Now we are going to discuss about the burglar alarm circuit using SCR. So in this burglar alarm is an electronic device. It is fixed at some concealed point. It rings a loud bell. If someone tries to theft the equipment, the circuit gives an alarm signal. This is also called as theft alarm. This is the circuit diagram for burglar alarm circuit using SCR. So in this it has the one resistor, one capacitor, one thyristor, switch. The switch will be connected to horn. And in this, the burglar alarm is an electronic device which is fixed at some concealed point that rings a loud bell if somebody tries to theft the equipment. This is also called theft alarm. In figure, it shows the burglar alarm circuit using SCR for protecting a car tape desk from theft. The switch AC is located at some concealed point in the car and is kept closed. Since gate G is grounded through the tape desk, the SCR is off and the horn is silent. If the tape check is removed, G is no longer grounded. Instead, it gets connected to the car battery through R. Consequently, gate current is set up which fires the SCR as a result. The horn starts blowing and continues to do so until S is open. So in this, the burglar alarm, the switch S is located at some concealed point and kept closed. The gate G is grounded, the SCR is off, and the horn is silent. If the equipment connected in the circuit is removed, the gate G terminal is no longer grounded. It gets concealed to the battery through R. Gate current is set up which triggers the SCR. As the result, the horn starts blowing and continues to do so until S is open. Now we are going to watch one YouTube video regarding to burglar alarm circuit using SCR. Now, just we watched the one YouTube video regarding burglar alarm circuit. Before going to complete this class, we will discuss another topic about emergency lamp circuit using SCR. So this is also same as burglar alarm, but here the lamp will be used in emergency. In this, an emergency lighting system which contains 12-volt battery at full charge and switches automatically from AC mains to the battery when AC mains voltage gets interrupted. The transformer and the two diodes D1 and D4 form a full wave rectifier providing suitable DC voltage. The anode A and gate G of the silicon control rectifier S are kept at battery gate 12 volts, which while the cathode K is kept at a higher voltage. If the AC power gets interrupted, the voltage of cathode K of ACR falls below the battery voltage. The ACR triggers and supplies the load with power from the battery. When AC power reappears, ACR turns off automatically and battery recharges. Now we can watch one YouTube video about emergency lamp circuit using SCR.
Center tap step down transformer when 230 volts is applied to the primary lighting system. This basic emergency lighting system is to be used for the various applications, for the household purpose, for the industrial purpose, and also in the emergency services such as the medical system. This circuit consists of step down transformer, center tap rectifier, SCR circuit, uh, C1, R2, R3, 6 volt battery, and diode D3 and R1. Whenever the input AC voltage is applied to this transformer, this is the center tap step down transformer. When 230 volts is applied to the primary side of the transformer, here the 6.3 volts is appeared on the upper half winding and the same voltage is appeared on the lower half winding. But during the positive half cycle of the input AC voltage, terminal diode D1 is to be forward bias. At the same time, diode D2 is to be reverse bias. And as the diode D1 is forward bias, we obtain the rectified voltage across the terminal A, having the maximum amplitude of 6.3 volts here. Again, during the negative half cycle of the input AC voltage, terminal lower half winding becomes to be positive and hence diode D2 is to be positive as compared to the diode D1. Diode D2 is to be forward bias and again the same rectified voltage is appeared at point A here, and maximum amplitude of rectified voltage is the 6.3 volts here. Whenever this rectified voltage is to be present at terminal A, here the current flow through the lamp, and this lamp is to be glow. Similarly, at the same time here that voltage is applied to the diode D3. Here diode D3 is to be on and current flow through the R1 and the battery, which charges the battery towards its maximum value of 6 volts. Here voltage at terminal A, which is to be connected directly to the cathode of the SCR, is to be higher voltage than the anode voltage here, and cathode voltage is 6.3 volts, and because of this reason here terminal A has the maximum amplitude of the voltage. Capacitor C is to be charges with the upper plate positive and the lower plate negative. DC voltage is to be established across the resistor R2 here. But as the cathode voltage is at the higher positive potential than the anode voltage, because of this reason SCR is to be off. Here we use the positive potential concept. Here SCR is turned off during the during the input AC voltage here present or applied to the circuit, and hence this diagram 2 shows that SCR2 is to be off here, because cathode is at the higher positive potential than the anode here, and hence here SCR is to be off, shown in the circuit. Now we have to study the situation. What will happen if there is the emergency failure of the input voltage? Emergency failure of the input voltage. What will happen to the circuit? If there is the emergency failure of the circuit, emergency failure of the input voltage, here the output voltage produced at point A is to be 0, and hence this rectified voltage becomes to be 0 here, or here becomes to be 0 volt here. Because of this reason here uh, cathode potential is to be changed, voltage across that capacitor is also to be changed. Capacitor C1 is to be discharged through the upper plate positive, diode D3 R1 and R3, and the lower plate of the capacitor which is to be negative. Because of this reason here cathode potential is to be dropped down, cathode potential is to be dropped down to 0 volts, and hence the its anode potential is to be higher than the cathode. And because of this reason here this SCR is in the forward conducting mode here, and when the proper gate voltage is applied through R3 to the gate of the SCR is to be triggered or SCR is to be turned on, and whenever SCR is to be turned on, this SCR is to be directly connected to the lamp circuit, which is to be shown in the figure 3. Whenever there is the failure of the input AC voltage here, battery is connected to the uh, lamp through the switch, that is the static switch, that is the SCR, and hence SCR is to be on, which connects the battery and the lamp is to be glow. Here again we assume that if there is the input AC voltage is to be appeared at that instant, here again the SCR is to be turned off here, and the lamp is to be disconnected from the 6 volt battery, and this lamp glow because of the voltage appeared at point A. In this way this basic emergency light system is to be worked. Thank you.
Hi all.
So now we watched the one YouTube video regarding emergency lamp circuit using SCR. So here the summary is today we discussed about the um, sealed maintenance free batteries used for backup, for low and short backup, and the lead acid battery used for higher ratings, and also light dimmer circuit consists of DAC and TRIAC is used by changing the firing angle of TRIAC. The voltage can be controlled thereby dimming the lamp, and also we discussed about the emergency lamp circuit using SCR. So here we have the few quiz questions and frequency asked questions. So this is the today's class. Next class we are going to discuss about the Chopper circuits. Thank you.